Hey, hey, 1, 2. All right. Hey, everybody. So my name is John, and this is going to be a presentation on zero trust architectures. So first, quick little what we'll be going over. First, we're going to do a little intro. Then, what actually is zero trust? A little explanation and some brief history. Then the components of zero trust systems. So we'll talk about these later. How it's actually implemented and what does that actually mean. And just feel free to stop and ask questions. I'd ask that you raise your hand, but I don't really care. And note that a lot of this is really higher level stuff, but if you want to go more in depth, feel free to talk to me. Okay, so quick little who am I? I'm not going to go over any of these, but if you see something interesting, come talk to me. Actual importance, though, is my work with NIST and their National Cybersecurity Center of Excellence, which is where I worked on the Zero Trust project, which is where I learned all this, and I'll talk about that later. Okay, so what actually is Zero Trust? Well, put simply, it is zero implicit trust granted based on network location. Pretty simple, right? Well, what does that actually mean? Well, in order to understand that, we need to look at the old guard of network security, which is the perimeter model. So this is the traditional model. The basic understanding, oversimplified, is that everything inside is good and everything outside is bad. And this can lead to some obvious problems. Again, this is quite oversimplified, but if you have a perimeter with an asset and you have a bad actor, let's say that bad actor gets inside your perimeter. Well, now you're screwed. It's game over. There's nothing stopping the attacker from moving laterally across the network, meaning from asset to asset. Again, this is quite of an oversimplification, but if this were to happen, you'd be in trouble. So how can we actually solve this problem? So enter the zero trust strategy. So the idea behind zero trust is the protection of subjects, which are human users. So that's could be humans or service-to-service communication or other clients, and resources, which are the actual data, applications, infrastructure, et cetera, that you're securing. So instead of the whole network, Zero Trust focuses on a per-access-based request from subject to resource. And the key part of Zero Trust is the assumption that an attacker has already breached your perimeter. And so you already have an attacker inside your network. We'll see later how this comes in hand. But just assuming that that first layer of defense is broken is key to the design of Zero Trust architectures and the components that they used. So these architectures are split up logically by the control and data planes, as well as the untrusted and implicit trust zones, which we'll see later. This is typically done using logical network separation, like VLANs, but there are definitely other ways to do it. I won't touch into because they can get pretty complicated. But as you see in this example, we have a human subject trying to access a GitLab server with the policy decision point / PEP in the middle that I'll talk about later. So our human, in a zero trust environment, our human will talk to that, and that will talk to the resource. Pretty simple, right? Well, let's take a little closer look at this. So firstly, what is this policy decision point? Well, it's actually made up of several components, mainly the policy engine and the policy administrator. And the element between our subject and resource here is actually called the policy enforcement point, which bridges the gap between the control and data planes, and it will actually allow us to talk to our resource. So we'll talk more about each of these components later. But first, we just want to understand that these policy decision point resources are located in the control plane, whereas the subject, resource, and the policy enforcement point are located in the data plane. And we can also split up the data plane based on our untrusted zone and our implicit trust zone. So the general idea is keeping everything in our subject untrusted, and then only the actual resource and the policy enforcement are trusted. So to define further, specifically from NIST Special Publication 800-207, this is the operational definition of Zero Trust. It's pretty long, but the key points are that Zero Trust enforces least privilege access per request, and that this architecture is comprised of the components, workflow, and the access policies. and we can define a zero trust enterprise by its network infrastructure and operational policies that are in place to actually implement zero trust. And as a last bit of prerequisite information here, some brief history. So the term zero trust was coined by Dr. Stephen Paul Marsh in his 1994 doctoral thesis, discussing trust as it relates to computation. And in the late 90s and early noughties, we started to look closer at the existing perimeter model and actually talk about, hey, why this is probably not the best. And in response to I believe it was a Chinese cyber attack in 2009, Google published the Beyond Court papers, which outlined the basis of zero trust security that they implemented as a response. But it wasn't actually called that. In 2010, the Forrester zero trust paper, published by John Kindervag, first actually started using the term zero trust in the context we know it today. And then most recently, zero trust was standardized in NIST's SP 800-207. And in 2018, the implementation guideline was written by the NCCOE. The standardized in 2018, and the implementation guideline was finalized in 2025 as SP 1800-35. So the core concepts of zero trust are not very new in the relative history of cybersecurity, but the implementation and standardization are still quite young. All right, so now let's go a little more in depth on the actual components that make up a zero trust architecture. Firstly is that policy decision point, or PDP. No, it's not a DEC computer. As mentioned previously, the PDP is made up of two components, the policy engine, or PE, which actually makes the decisions per request, and the policy administrator, or PA, which is responsible for making and breaking the connections between subjects and resources. Again, they are usually combined into one singular piece of software that provides both logical functions. But overall, you can think of the PDP as the judge, jury, and executioner. So as I said, the policy engine, the PE, is the ultimate decision maker, acting as the judge/jury. And it does this with a trust algorithm. Now, there's a lot of different variations of trust algorithms that I'm not going to get into the nuances here, but the basic idea is there are two main differentiators, and that's criteria-based versus score-based, and singular versus contextual. So, I'm sorry, let me click on the wrong button. So, criteria-based algorithms assume a set of qualifications that must be met to grant a request. So you have to have X many, like you think of it like a checklist, right? You're checking down each thing. So once you've met a certain number of checkboxes, you're good. Whereas score-based algorithms will compute a confidence score through the predetermined weights that are set. So you have a weighting for each item, and that when that score meets a certain threshold, it's granted. And then singular versus contextual trust algorithms describe the ability of the trust algorithm to consider multiple requests at the same time. A singular trust algorithm, of course, can only look at one request at the same time, whereas a contextual can look at multiple at the same time. But regardless of the trust algorithm being used, they are all influenced by the written policy and the data from PIPs, which I'll discuss later. Of course, the PE logs its decisions, which it can then use later as more input data. And it's given requests from the PEP, and it sends those requests from the PA to execute. So again, you can think of it as the judge/jury in this like courtroom model. So next is the policy administrator. As I discussed, it manages connections between subjects and resources. Specifically, it commands the individual PEPs. The PA can generate session authentication tokens or other means of session authentication, and it communicates with the PEP on the control plane. You can think of the PA as the bailiff in this courtroom analogy, and as previously mentioned, it's most commonly combined with the PE to form a singular PDP product. So again, you can think of that as the bailiff. So circling back a little, as I said, the policy information points, or PIP, are the actual input data that's fed into a trust algorithm. to make these request decisions. Now, this input data can be from a lot of different things, depending on the trust algorithm. For instance, can be from a continuous diagnostics and mitigation system, or a CDM system. It can be industry compliance. It could be from a threat intelligence feed. It could be from network and system activities log, data access policies, public key infrastructure system, an identity credential access management system, or ICAM, a SIM, or security information and event management system, many, many others. There's a lot of different data that you can pump into one of these trust algorithms, depending on your trust algorithm, and you can use all sorts of data to feed that decision. So lastly, we have this policy enforcement point, or PEP. So the PEPs enable, monitor, and terminate the connections between subjects and resources. So they are the connection between the data and control plane. The PEPs, a lot like the trust algorithms, can have many different arrangements and architectures themselves. For instance, they can be more of a client resource model, where the PEP sits directly in front of the resource, and that client has like an endpoint agent on it. Or they can act more as a gateway portal, where the PEP is its own entity that sits in between the subject and resource. There's a lot of different configurations, all with their own benefits and specifications, and it really depends on the scenario for that resource and subject. Theoretically, you can have all different kinds of PEPs in one system, although typically you only really see one kind per enterprise. As previously mentioned, they have an implicit trust zone, so that the PEP can actually interact with the resource. And remember that we're using least privilege access for the client, which doesn't restrict us from having that implicit trust necessary to communicate with the resource in the first place. And you can kind of think of these guys as the gate guard, kind of in that courtroom analogy. But there's, for each resource, you'll have a PEP. All right, so now let's talk about how we can actually implement these components and tenants into the system. So you might be thinking, what do we actually do? Well, this is where the tricky part comes in. So there's a few inherent issues with implementing Zero Trust that make it a little difficult. Firstly, there is no one product solution to make your enterprise a Zero Trust architecture. You have to have a lot of different products working together, a lot of moving parts in one machine. It also requires full organizational support. You can't really transition part of an organization to Zero Trust without the whole organization. Now, granted, that's easier if you're building Zero Trust from the ground up, but you still need the whole organization on board. Furthermore, it requires a foundational organizational structure. Again, a lot easier if you're building from the ground up, but if you've got an existing system, you have to have these network and resource structures built for Zero Trust. And lastly, and hopefully what this presentation can help with, is that the lack of common understanding of Zero Trust topics. One big problem is that a lot of people just don't really know about Zero Trust. Maybe you've heard of it, and maybe you think it's something that you can only really implement on a really large scale, like with a giant government organization. But hopefully, in talking about Zero Trust and the more recent publications from NIST, as well as the increasing availability of Zero Trust tools, that problem can be solved. Now, one thing that might have caught your eye, if you've ever done, well, really anything with IT, is that requiring multiple products working together is an absolute nightmare. And yes, it certainly can be. I'd say this is where the bulk of difficulty in building Zero Trust environments comes from. However, like Leah and everyone else was talking about earlier today, one thing that really helps, that I personally found to help, is a lot of those infrastructure as code tools like Terraform and Ansible. At NIST, I did a lot of working using these tools to spin up and scale lab environments. Sadly, I can't share any of that work, but it certainly helped me learn just how powerful these kind of tools can be in deploying these large, complicated systems. But anyway. All right, so what do I actually do if I want to create a Zero Trust architecture or transition my environment to Zero Trust? Well, our first step, like many security processes, like risk management, is to analyze our current state. Now, if you're starting from scratch or migrating in an existing environment, this might look a little different. However, the core step remains that we need to actually identify the assets that we have that actually need protecting, what our subjects are, and how resources are utilized. If we're migrating an existing environment, we need to review our current access policy. So what do I, a user, need to do if I want to access a resource? If we're starting from scratch, we still have to look at this. How will our resources need to be accessed? So then we actually need to create this new access policy. And in a zero trust environment, of course, we need to do so while conforming to the principles of least privilege and separation of duties. Access policies should be created to authorize subjects with least privileges required to perform their tasks on a resource that they are permitted to access. Basic stuff, but it can get a little complicated with zero trust. There's a few things that you should consider that you might overlook normally. So consider this following example, right? Let's say we are an organization based in the US, and we get a request from a client originating from Belarus at 3 in the morning, attempting to access an important document. Now, obviously, this is typically something that would raise some alarm bells, but maybe our organization has contractors in Belarus who are logging in at lunchtime in their country and performing their work they're supposed to be doing. Now, while this is a scenario we might analyze normally in a security context, the key things that we have to look at here are location, time, the asset itself. All of these can be used to help create a better policy. While a lot of the power from zero trust architectures comes from that trust algorithm's ability to take in a lot of different information and make a decision, if it doesn't have a baseline to go off of, it's not as powerful. So we need to make sure we're writing good policy. All right, so continuing on, now we can actually start to implement some software. So first and foremost, we need to make sure that we have the tools to support our zero trust components. So this includes security tools like SIMs and vulnerability scanners, but it also includes the underlying infrastructure like our ICAM system to provide user information, among other things, as well as multi-factor authentication and endpoint protection. These components are crucial to the functionality of our zero trust components, not only providing information in the form of PIPs, but actually supporting that system. So now we can actually start to implement our zero trust components. So of course we're going to need a PDP, and there are many options to choose from open source solutions to paid cloud services. Then of course we need a PEP to actually support our resources. As mentioned previously, there's a lot of configurations these PEPs can operate in, and naturally there's a lot of options. Lastly, it's important to note that our ZTA must evolve over time. Oh, I'm sorry, I've missed one. It's also important that we can actually integrate all of our applications with our products. So that's something we need to take into account. So it's important that our ZTA evolves over time. We can't just implement a few pieces of software and forget about it. In order to maintain the best security, we have to continuously reevaluate our zero trust environment and configure and possibly change or upgrade components. So you can see it's a large endeavor. As I said, there were a lot of options. Well, how do we actually choose what option is right for us? Well, Special Publication 800-207 outlines these questions for choosing components. And I've paraphrased them slightly, but they essentially ask the following. Firstly, does the solution require components to be installed on the client asset? Well, this is important to consider if we're using non-enterprise owned assets, like in a bring your own device office setting where workers, employees are bringing their own laptops to use. Secondly, will the solution work for both our on-prem and cloud infrastructure, or both? Some solutions are cloud-based, while some are on-premises based, and depending on the structure of our assets and infrastructure, this can be a very important consideration. Next, does the solution log interactions for analysis? Obviously, this is a key principle of zero trust. We need to be able to collect data and feed it back into that policy engine. Next, does the solution provide broad support for different applications, services, and protocols? And again, obviously, depending on the assets in our network, this can be crucial. Some products will only work on like the web plane, and while that might be perfect for one enterprise, it might be completely useless for another. And lastly, does the solution require a change in behavior for a subject? Now, this is a critical one and could realistically be a whole nother presentation in and of itself. Additional security will often require additional or different behaviors from our users/subjects. And there can be a limit where users get so annoyed from having to do these additional steps that they might start to forego our controls entirely or just not be able to work to their full potential. So there's a balance between security and usability that we need to consider that's crucial for these solutions that might drastically change the behavior of our user. And I put some little examples here. You might have heard of some of these companies like Zscaler or Okta or AppGate. Lookout, Ping Identity, that is the Microsoft Entra ID logo. It used to be called Azure AD, but they changed it to Entra. Same thing. and IBM Security. These are just a few of the many companies that offer zero trust solutions. And again, while they all offer different parts of the zero trust, there is no one product that you can just say, all right, I want that, give me zero trust. All right, so we've got our zero trust components deployed in our environment. Well, what does this actually mean? Well, let's go back to our earlier perimeter example, this time with the ZTA components in place. So if we have our asset in the data plane here, and our bad actor comes up wanting access, they're going to be stopped by our PEP. Let's say for this example, it's a portal configuration, so the subject will ask the PEP for access to our asset and present relevant information about the request. Our PEP will then go to our PDP and provide it with all the information it has about the request. And the PDP will then make a decision using data from its written policy, its ICANN systems, logs, the SIM system, CDM system, whatever, right? And it has two decisions it can make. Firstly, it can say, okay, cool, let him through and approve the request, or it can say, no, go away, and deny the request, right? If our request is denied, our PEP portal will block the request for access, and policy might prevent our subject from further requests for a period of time, depending on our trust algorithm. We could do a lot with that. But let's say for whatever reason that the request was approved. Maybe our bad actor is an insider threat that should have access to this asset. Well, even if they were to gain access to the asset, they're of course going to want to move laterally and gain access to other assets on the system. Well, here's where the beauty of zero trust comes in. Because our access is per request, the bad actor cannot move laterally, and they are stuck. And our bad actor is now sad. They have failed. Okay, so what are some of the benefits of using a system like this? Well, firstly, we have a much more secure access control. Access is granted based on strict authentication and authorization checks, regardless of network location. Secondly, zero trust allows us to operate contextually, taking into account information from all over the system for each request. While some trust algorithms might not operate contextually, it gives us this opportunity to do this. Next, zero trust systems continuously evaluate access and applies policy in real time throughout a session, which ensures that even after access is granted, it's continuously verified. Zero trust also allows us to protect these hybrid systems consisting of resources both on premises and in the cloud. And again, regardless of network location, which can be really powerful if you have a really complex hybrid architecture. Zero trust can also, I didn't click the button, I'm sorry. Zero trust can also protect an organization from external threats. So let's say if we're working with another organization on a project, well, that organization's security is out of our control. But we can ensure that our resources remain secure. Zero trust also gives us secure sessions for data transfer, ensuring that data in motion is secure as well. So you might think, okay, perfect, shut up and take my money, right? Well, of course, with all these benefits, there are potential threats. These specific threats were outlined in SP 800-207, some of which are a little outdated, some of which have changed, but all of which still remain. So firstly is the subversion of the trust algorithm. So if an attacker were to compromise the policy engine or policy administrator, they could, of course, disrupt operations or grant unauthorized access. Obviously, that's a big problem, so we need to make sure that those are secured very well. Subsequently, attacks on the PE or PA can result in denial of service or network disruption in general. However, redundant or resilient PE/PA systems can help to mitigate that risk. Next, while encrypted traffic may be practically useless to traditional monitoring tools, having all of your data under one roof can aid in the analysis of data using things like machine learning to flag traffic patterns. Next, the information on our systems and network can be a big target for attackers. So it must be tightly protected. Knowing how our zero trust system is built can be a big target for an attacker. Of personal importance to me is the resilience on proprietary data formats or solutions that some zero trust solutions require. Vendor lock-in is a big problem in the field and an existing problem identified by 800-207. It's something that is getting better, but since there are so many different components that go into these zero trust systems, it's difficult to write one standard or one protocol that covers all bases for everything you need. So vendor lock-in is still a pretty big problem. Lastly, automated systems like AI administering zero-trust systems can leave the whole system vulnerable to weaker authentication mechanisms or social engineering. In general, highlighting the problems of AI-managed security. Um, so, obviously, there are some problems, but personally, to conclude, here's my 2 cents. Of course, take this with a grain of salt. I'm a student, and those who know me well will know the other reasons. But personally, I believe that a properly implemented zero trust architecture greatly reduces the overall risk to an organizations. And of course, I say properly implemented because while it's difficult to set up and maintain these systems, I believe it's definitely worth it in the long run. Of course, as everything with security, there is a lot to be done in the field to enhance these solutions, tenants, and tools. It's a lot of work. We get a lot of work to be done, but I think right now they're in a pretty interesting state to learn about. So I briefly mentioned I learned about all this while working on the Zero Trust project at the NCCOE. I'd like to thank my colleagues there for teaching me a lot of this and helping me learn everything else. And I'd like to thank you all for your time. So here are my sources. If you're interested, that first one is the one that I worked on with the NCCOE. A lot of the funny black and white illustrations came from the last one. So yeah, that's it.
Is there any questions? I mean, do you want to stay in
Oh, yeah.
questions? And
Questions?
people have any?
Yes.
Can you clarify the difference between the PDP and the PEP?
Yeah, of course. So the major. Oh yeah. Can you? The question was, can you clarify the difference between the PDP and the PEP? So the major difference is that that policy decision point lives in the control plane, and the policy enforcement point lives in the data plane, right? So the policy enforcement point is the entity that you're actually dealing with from a user and resource perspective, right? The users aren't going to be talking directly to the policy engine. They're not going to be talking directly to the policy administrator. They're talking to that policy enforcement point, right? You can think of it like a gate guard, right? If you go up to a gate at a facility, you're not going to get on the phone with the CEO and ask if you can come in. You're going to talk to the gate guard. The gate guard's going to talk to his boss or their boss and ask, okay, can this person come in, right? And they're going to make that decision. The PEP doesn't make any decisions. It only allows that connection. And that can be done through many ways. It can be done through a simple tunnel. It can be done through microsegmentation in the network. It can be done through other tunneling methods. There's a lot of ways you can do that. But the general idea is that you, the subject, are talking with the PEP, and that PEP talks to the PDP to actually confirm your request. Any other questions? All right. Oh, yes. I don't know what I would do. Yay! Thank you.